I'm starting the live stream. Hey, this is Chill Maths on Twitch. I'm James, and I've changed my setup a little bit. I think I'm live. It's hard to tell. Oh, Maths2222 is here. Maybe they can let me know. Am I on the internet? I think I might be. Hello, Mary, as well. Good to see you. Hi, everyone, again. We're going to pause a little moment while people let me know whether I've done this or not. I've had an exciting week. I've been off doing other things in other places. Hi, Booman Will in chat. Hello, good to see you with us as well. Right, good. Okay, I'm. Interesting answer. Yeah, okay. Well, you see, this is a good joke. It's a good joke, but also I do need to now check, just in case it's like some incredible meta play where you've realised I'm a minute late and you're guessing. No, Twitch is making it sound like I'm definitely here. Thanks, yeah, you see. But now I've double thought it. Maths222 playing the guard who always tells the truth and the guard who always lies at the same time. The guard who alternates. Yep, I don't know what to believe anymore. What is true? I'm going to keep talking anyway. So I went to a big conference this week, and I met lots of other maths people who talk about maths. The conference has got a name on a version of talking maths. The conference is called Talking Maths in Public. I met lots of other people, and one of them told me how to set up Twitch properly. So I've tried doing that. Yes, time-based alternation. So I need to ask you really rapidly. Do you know the quantum version of that? Oh no. There's the quantum thing about time-based switching between two states, which you might or might not have met. Can I remember how it works? Something like probability. There's a rule for which state you find something in. It's a probability thing, and once you've observed it, it's in one of the states or the other. This is a quantum state thing, and then the rule is that while you're not observing them, so after that, time evolves, and the probability changes according to something that you might call the Schrödinger equation, and that means that after a while you can predict the probabilities that you see each of those two states. But this means that if you time it just right, there's a 50-50 chance that you get to each of the states. And if you time it just right, there's a 100% probability that you'll see the other state. You can make it flip, even though it's uncertain. Can I remember how that works? No, I'm not sure I can. There's also I can't remember the evolution operator for two-state system, which is quite embarrassing because that's the sort of basic version of quantum mechanics. Anyway. Rubbish. I can't do the maths for it. Maybe I should go and look that up. Could be a thing to learn. Hello, Mean Machine Rex in chat. Good to see you too. I'm trying to remember quantum mechanics. The punchline that I heard for this was something like, so you do observation and you find out that you're in state 1, and then the probability oscillates like this. It's some sort of sine squared thing, I suppose cosine squared. It oscillates down and up and down, which means that if you get it very quickly, then the probability is surprisingly close to 1, because this graph is flat at the top. If you're at time t, for a very small t, the probability is about 1 minus t squared over 2 or something, for this kind of quadratic approximation to this thing. Which means that if you do lots of observations, separated by separate team, it resets after each observation you do. It starts doing this sort of cosine thing again. Then, as long as you do the observations fast enough, you can get the probability really close to 1 that it just stays in that state. This quantum stuff is really weird. There's only really this rule about how things evolve, and this rule that when you observe them, you get one of the outcomes with some probability. And after that, it starts evolving with time again. It's just super weird. There's this thing called quantum kettle. So you do these really frequent observations, and that can force it to stay in the state it's currently in. So of course the way that people describe that is by saying that a quantum kettle never boils. Or this thing, it's that phrase, a watched pot never boils, but in the quantum world that's literally true. If you observe it fast enough, you can keep it in the state it's currently in. The bit of the maths that I remember is that you do very small, so you very small t, maybe t is 1 over n, say, between 0 and 1, you're doing this kind of 1 over n. You've only waited 1/nth of the time before checking. And then this probability 1 minus 1 over 2n squared, and you want to succeed n of these, so that it stays in the same state all the way through. This is a little bit hard to think about because it's like coin tosses, where you have sequence of coin tosses, and they all have a probability, but the probabilities also depend on its external parameter, which is time, really, but kind of like frequency, I suppose, as well, if you're doing lots of observations in fixed time. So the result is that this thing, as n goes to infinity, this exponential goes to 1. That's not obvious at all. And it's because this thing to the power of n would go to e. What do I mean? So there's a thing where if I have matching powers down, if I have matching numbers down here and up here, then I get that 1 minus 1 over n to the power of n fact, which is e to the minus n. What do I want here? I kind of want to say these are really close to 1, so this thing is really close to 1. How do I do that? I mean, informally I do some sort of like Taylor expansion, and I say, well, the next term in this expansion after the 1 would be 1 over n. Yeah, take logs do L'Hopital. So the frequency is known, by the way. This frequency, this is fixed, or maybe we'll say like known. It's not a weird thing. I haven't remembered it, but it is a thing. Shall we look it up? I've got a new system, which means I don't have the web open unless I want it to be open. So I'm just going to do that and pull that over there and try not to open any of my shortcuts. What do I want? I want the time evolution. We're not doing the 13. The 13 cards have not come into play yet. I got distracted already by quantum observations and flipping between true and false. Right. Okay. So if you take lots of observations, can you work on the frequency? I see. As a kind of general problem about cosines. I suppose you never really know. There's a thing called you never really know the frequency because of something called the Nyquist frequency, which I'm going to invite you to Google Nyquist frequency, which is something to do with observations and oscillations. I'm going to invite you to Google that while I Google quantum time evolution of a two-state quantum system, because I really can't remember. It's something about the energy as well, which, oh gosh, okay, here we go. Yeah, okay, shall I go on Wikipedia? Is that going to be a good thing? Am I going to have a good time today? I'm not sure I'm going to have a good time today. Oh no. Have I got to decide what the energy is? I'm not having a good time today. My Wikipedia search is going all like this. I can't remember how any of this works. Time-dependent Schrodinger equation says this, with an h bar in it. So maybe it's this. Oh dear. So have I got to decide what energy my two states have? I don't really want to do that. What is all this? I don't want to do pre-session. Okay, I'm not reading all of that. Right, something else. Oh, it's just started chucking it down outside. That's fun. Another time. Right. Probably distribution of frequencies. Yeah. So my sampling point for this is that you could observe it doing. You could observe it doing this, and think that the right thing to do is to join the dots, but there is another wave that goes through all those dots with a much higher frequency, which does like basically an entire period each time. I think. I think that's true. Can I prove that? So I'm trying to claim that there exists a value of omega that goes through, such that sine omega t goes through all of those points. That would be big if true. Can I find it to demonstrate this? Because really this should be a Desmos thing, right? Where I show you the points first, and then I show you not the sine wave you're expecting that goes through all the points. Which I'm pretty sure is the thing. Because if all the points, I've drawn them on as a sine shape, but if all the things are flat, then you can thread a sine wave through them, or you can thread twice the sine wave. So maybe that's it. Maybe I need to add a sine wave onto this one. Then I'll have sine waves of different frequencies. Nt? Maybe some pi's in here or something. When you add sine waves together, you get the product of sine and cosine things, which is not quite right. But I don't mind. No, I do mind multiplying this. So maybe you can't. Maybe that's not quite a. Maybe this is not a thing. Because your criticism for this is that's not a pure sine wave. So you wouldn't write that down. You would just draw the sine wave that goes through all the dots normally, because you're looking for a single sine t. If you know it's of the form sine omega t, you're not going to mistake it for this mess, right? Because you're looking for just sine omega t. I'm going to mess around with this a bit, I think. Hello, welcome back to the show. If you're new here, the thing that happens is that I talk to chat a bit, and then I get distracted trying to remember some maths that I once knew, and then we explore it to try and see whether we can look it up, remember it, work it out, or just do something with it. That's what we're up to. And then maybe we're going to learn some quadratic equations or something, quadratic forms or something. But I want a bit of a summer break from quadratic forms, I think. We'll see. So what was I thinking for this thing up here? I was thinking something like, for that probability. Sorry for all the ads, Rex, but they are supporting charity medium term. I think I'd say long term, actually. Oh, and I need to change my goal, don't I? So I met someone at the conference who pointed out to me that I might be out by 2 or something, but what's my goal down here? My goal is out by 2 or something. The goal is based on Wikipedia, and it's set to 315. I don't want to automatically level up my gold. Why am I not allowed to change my gold? Oh no. I'm not allowed to change it now, it's in progress. Okay, update goal. That actually worked? Did that do anything? With this goal on the bottom of the screen, it sort of blends into the scenery, right? Because it's been about here forever. But with this like follower goal, when we hit 196, when we hit 196, a tricky square number, and built that massive Minecraft thing, we set a new goal of 315 because I, at the time, believed that it didn't have a Wikipedia page. It's been pointed. I've told some people this, the sort of people who know this sort of thing, or have access to Wikipedia, which is all of us. And they've pointed out that it does have a Wikipedia page, and so does 316. So I don't really know what I was thinking. You say it now has an article. Somebody in the pub told me that it's had an article since 2006. So what's going on there? Are they creating them faster than... What's going on? I don't want the calendar year, I want the number. So 315 has this Wikipedia page. How do I find out? Can I view history? Was this always here? Was this always here? So 2025. All of this works in 2025, but there's some stuff in 2024. So what was this? Created 2006, and then something happens in 2019, which retarget to, I don't know what that means. Possibly, then there's a bunch of these. So how do I look back? I want to know exactly when, like where's the progress point, right? Where did this start having a thing? Was it 15th of October 2024? Let's look at this in previous or something. There you go. Okay, so as of 15th of October, a user added the Wikipedia page, line 1, 315 is the smallest positive integer without its own Wikipedia page. And they did it creating, I think, its Wikipedia page. Next edit, removed. And set back as a redirect to the page 300. And then what? A very interesting number. Okay. So other people are having the same sort of joke as us. It got changed back to a redirect. It's very interesting. Right, okay, so people keep bouncing around in late 2024, fighting over whether it's interesting or not. Here it goes. And then someone just says 316 and that gets changed back to a redirect. So we're having a battle with like other users, right? Or not us, but this is a draft. Does that survive? At what point does it turn into its current Wikipedia page? This is brilliant. There's people just adding the phrase 315. No, it redirects to 300. Redirected to 314 or 316. Is this it happening in March? In March? Is someone slowly adding information? Are they adding enough? 10th of March. They're saving it every word. Mathematical properties. Ah, right, here we go. They're adding the box in May. So somehow in May it stuck. It didn't get changed back. Oh, it didn't get changed back. And then it got changed loads. It got added, all of these mathematical properties got added by, hats off to Afonso Dimas Martins, as of 5th of May. And there's something that happened between March and May where it didn't get changed back to a redirect to page 300. So here we go. It's got an article now. So that's pretty good. So let me find this person there. They're doing this. Copy the properties. Pages of similar numbers. Here you go. They've got a comment on it to let us know what's going on. I wonder if they've also done irresponsible for 316. There you go. So it's a pretty short number, but they have this fact as well, which is very good. I wonder if they've done 316 as well. And I also wonder if that fact, there was a fact for a while, either on the 300 page or on the 314 page, there was an incorrect fact about what the largest number on Wikipedia is. Yes, and then it's just people tidying up the page, right? And now it survived. Okay, so about May, this just turned into a page. It's not the most amazing page, is it? But I think we'll take it. Can I just read the page? So this is the page on 315. And 316 has also got a page now as well, which looks pretty good. When did this one kick off? So it looked like this one kicked off in about July. So it was a couple of months later. So we're due one, aren't we, for this? For 317. Let's have a look. So 317 got the same page? No, 317 links here. Even though it's got some facts about being left and right truncatable, so I reckon that one will happen as well. And the 318 does have a page already. So it's just a mess, isn't it? So how is this the fact thing? Is this the fact that it's the largest thing not on Wikipedia? Well, that's been updated, I think. This is pretty good. Okay. So I think we're now happy. 314 is on Wikipedia, obviously. It's the first 3 digits of pi if you multiply it by 100. It's even. That's a fact. But now we've also got 315 and 316. So, fair enough. I wonder if this is precisely what happens when you search for 316 on OEIS. 1, 2, 3, 4, 5, 6 results. Or 6 references for places where 316 turns up. I wonder if 317 is going to be a bit like that. And then I think 318 is kind of an exception because I think 319, none of the others are going to have pages. Oh no, they do. Some of them do. What is going on? For some of them, people have really tried. Okay, so there's a bit of a mess after that. Okay. Why is infinity not on the real number line? Because it's not a number. Same reason my cat is not on the real number line. Because my cat is not a real number. Right, okay. I tried to change my goal up. I tried to update my goal. I even have a message that says goal updated. But am I supposed to end goal and restart? Oh, I don't know. I think I might delete it. Look, we'll get to 315 and then we'll remember this and then we'll get a couple more followers. A couple of people who have unfollowed will refollow again and we'll get there for the kind of proper finish line. 317. Is co-zero like some sort of category theory opposite of zero? Right. Okay. Right, what was I doing? Probably not this. Gonna mess around with that power just a bit moment because it annoyed me a moment ago that I couldn't immediately work out why is this like this? Is that true? Is it E or is it? Maybe this is my problem. I don't know if that's true or not. I sort of feel like this is going to go to 0. Am I being a silly person? Maybe I'm being a silly person. What is the general rule here? If you get 1 plus x of y, that's not a good question. That is not a good question at all. I'm vaguely aware of some facts, right? I think the main fact I'm aware of is that 1 plus 1 over n to the power of n, I think that tends to e. I think if I put an x in here as well, this tends to e to the x or something. For fixed x, the limit as n tends towards infinity is e to the x or something. Yeah, thanks. Okay, with a in chat as well. Oh, did I miss a minus sign or something? Embarrassing. Because, yeah, okay, maybe I briefly on the board had this with a -1 in here. Let's tidy up that x. So, ideally I would like to just use that fact, right? I don't think I'm allowed to set x to be equal to -1 over n. That doesn't feel very fixed x. Although morally that's going to give me the right answer, isn't it? It's going to give me the answer that I want of 1, which I'm not going to run with. So maybe, yeah, okay. Can I do some sort of substitution that's really clever? How does this work? How does any of this work? Can I do a substitution? So the thing inside is like this. So u is -1 over 2n. That's quite tempting. Because then, no. Oh, okay, so this is quite good because then I'm asked for the limit as what am I doing? As u tends towards 0 of 1. I don't like this at all. Don't like this. No, not that. Not that. I sort of want this to be x over n, I suppose, but it's really not. Yeah, I know you want me to do logarithms and L'Hopital on it. I know. Quite keen to do it this way, but maybe just using this one fact I know is not that good. You're not allowed to plug in a function x as a function of n, otherwise all sorts of things go wrong. It takes 2 machines 2 minutes to make 2 donuts. How long would it take 150 machines to make 150 donuts? This is one of those tricks, isn't it? Where there's more donuts to make, but there's more machines making them. So I think the answer turns out to be like 2 minutes, but I haven't thought about that. That's my gut instinct that it's still 2 minutes at the top. They're all working in parallel, so they make more donuts just because there's more of them and it doesn't take longer. Should I do the numbers? No, I can't be bothered. Is it 2 minutes? Right, I'm going to take a logarithm. I'm going to do what chat says. Yeah, I'm going to do what chat says. I'm going to do what chat says. The log of that is this, and then I can rewrite that as this. I still want the limit of this as n tends to infinity, which is 2 things that go to 0, because this will be log 1 minus some very small thing, and this will be 1 over n. So L'Hopital says I can do this. L'Hopital says I can do this, and also I want to do this. Oh gosh, so I get 1 over n cubed out here, and 1 over something like this. Something like that. That looks good. probably I'm good now. Yeah, that looks like it might be 1 or maybe -1, depending on where all these 2's are coming from. Messed up the derivative with respect to n over here. I don't really like doing n goes to infinity, changing into x goes to infinity, but here we are. Here we are. Why have I messed that up? Am I happy? Not happy. N's go to infinity, so it's a little bit less than 1. I'm worried about that minus sign. Can I get rid of it? Oh, no. This is going to minus... What do I want for this? This is the logarithm. So I'm sort of hoping that the logarithm of 1 that this thing is going to go to 0. Maybe I should multiply it up. Maybe I should multiply it up. So I get n squared after multiplying top and bottom by n squared, and down here n cubed minus, why have I done it like this? N over 2. But good news that this denominator is like n cubed, the numerator is like n squared. So maybe if I do the sensible thing and actually divide the powers first, then I'll get 1 over 1 minus 1 over 2n or something, which definitely goes to, oh no, n minus n squared? Yeah, which definitely goes to 0. Okay, so log this, log of that goes to 0. So that thing that we had, the probability goes to 1. Good, okay. That's the only bit of maths I remember from that. And Streamlabs has managed to moderate chat a little bit, which seems pretty good. Mean Machine Rex, have you just got like a book of maths puzzles or something? Or have you done a Google search for tricky maths problems? If you'd just joined chat and brought your logic book of tricky maths problems, then I'd be like, who is this? Oh, where did they get this book of tricky maths problems? But you're here every week and you've just decided to start testing me. Like, you know I can't do it under pressure. Yeah, that's the 10-hour thing. Hang on. For the Petri dish one, you're supposed to tell me how long it takes the bacteria to double. It's 1 generation ago, but I don't know how long that is. Right? Because if the generation is 10 hours, then the answer is 10 hours. It started half full and now it's full. Does that go to 0? Yeah, when n is large, right? I think so. Just like puzzles. Oh, good. Okay. I think we might do the card-based one in a moment, which is quite a good puzzle. Well, it's quite involved. Have I divided it right? Yeah, I reckon this is good. Does that go to 0? It's got an n down here. I messed up and wrote 1, but I meant n. Yeah, it looks like it. The logarithm and L'Hopital was the right strategy. I'm annoyed that I haven't been able to adapt to that though. Limits. Been a long time since I needed to do those. Nyquist frequency. That's my naive idea of how to send it through here, but maybe I can. So what happens if you sample a sine wave? You get something periodic. If you sample a sine wave every... So if you sample a sine wave, but less frequently. Whoop. This goes over here. Okay, new idea. So we're going to sample this. It's secretly sine x, but we're going to sample it at some points. So my points are called A because I love calling things A. I could do live coding in Desmos. We're going to take some samples. I want them to be, I suppose, all the way across the screen. So I'm going to go -10 to 10. And there's some sample rate in here of 0.1 or something, which I might want to change in a second. We can do that. And I want to look at the points where you evaluate the sine curve, but only on those points. Oh, is it not happy with me here? What is it not happy with? I don't like my colons. What about that? Ah, it's not colons. Colons is how MATLAB works. You're supposed to write this. -10 plus. Been a while. How are we doing, chat? There we go. That's my dotty sine curve. What was I doing with this? So if you sample sine wave, you get something that looks like a sine curve. Look back to Desmos. The sine curve looks like sine curves. And then the question is, if you see these dots, can you retrieve the sine wave that they belong to? Which the answer is probably yes. I give you a sine wave, and you think, what's the right sine wave to go through all these dots? Oh, it's going through all the dots. I did it. A sort of mysterious factor. If I put some say unknown function f of x at the top, apply it to this, and then you've got to try and match up the right value, right? It's a little matching game. Yay! The answer was 3. That was 3 up here. Yes. Okay. Great. But then the question is, if I make k really enormous, to the tune of basically an entire oscillation in between these points, can I go through the green dots anyway? And it's not obvious to me that the answer is no. Can I really not have any wave like that goes through all the dots? So something like that actually looks quite good. So that's quite close to going through all the dots, isn't it? I love Desmos so much. That looks quite good. I've set it to 66, and maybe the correct answer was 66 after all, not 3. And then question, what's the relationship between 3 and 66? Yeah, so said differently, if I put 66 up here, then I get something which looks a lot like a sine curve. But you wouldn't guess that it is this sine curve, because it really is now. Okay, so for these samples, for these values of A, sorry that it's called A, 66x and 3x kind of look the same. Let's have both, just so I can just kind of demonstrate that. And the question is going to be, I haven't quite tuned it, have I? Let's tune it. Oh no, don't change that number now. Now what am I doing? So same samples. Try and line up the green dots and the blue dots. What am I doing? I've put the K everywhere now. No, I hate this. What am I doing? Don't show me the graphs, show me the curves. See if I can make them join up like that. If I set them to that. Or, here we go. That's more like it. That is quite nice, actually. Sampling sine waves, sometimes like that. Oh, this is great. So 32. 32 is quite close to a multiple of pi, right? If I put in 314 in here, well, I get something that looks like an absolute mess, but 32 looks a lot like, so that's actually 3.14? No. Oh, that's amazing. Oh, this is great. What are we doing? We've got some sine waves. We're trying to match it up. The obvious answer is 3. That's pretty close. The correct answer is 66. And if you put in 32, that's not bad. There's a game here to work out. That is quite bad. You get some mad pattern. There's a game here to work out when does it look like that. Ooh, just coming down on the frequency channel there. Okay, and it's about evaluating sine. So you should probably match these up. Yeah, we got some weird DNA thing in there. I kind of like this one as well, which looks a lot like. What is this? Triple DNA, right? Thinks hard about how DNA, the acronym, might change if it was triple. Would it change? Oh, what does DNA stand for? We've done regressions on it. Ooh, amazing. No, DNA would still be DNA. It is properly raining out there, my goodness. Good day to be inside. Like, there's a kind of flow. I'll draw what I can see, sorry. Because it's okay, there is a house out the window with a roof like this, and the rain and the wind are coming in like this, and then there is a fantastic like over the top. It's brilliant of the, I guess, the wind blowing up here and then going wow everywhere. Fluid dynamics. Right, okay. So sampling a sine wave can give you weird shapes, and in particular it can give you things that look like sine waves, whether or not. Deoxyribonucleic acid. What is? I think the oxy is a, yeah, right, okay. So I remember ribosomes being a thing. So I think ribo is a syllable, not a syllable, but like a, no, not a phoneme either, but like a group of letters. Deoxyribonucleic. I don't know, my new theory of groups of letters, right? Oxy groups together. Never mind. Okay, probably still deoxyribonucleic acid, but we've moved on. Okay, so when are these sampled sine waves the same? I sort of think that 0.1 might not have been the best choice here. This all rides on this 0.1, I think. Let's write down the equation, I think. We would like... let's write it down. When does sine AX... Oh, I should not use A. I've already clumsily used A for something else. When does sine KX equals sine MX, not for all X, on the points X equals, and then all of the things I have are actually multiples of 0.1. I started at -10 and went to -10. Those are multiples of 0.1. So these are all on X's. So we use 0.1n for all n integers. Positive or negative. I mean, it's odd, so it'll do both. Let's put n in n or something. Okay. And this 0.1, I can maybe change it and rescale stuff, but so I'm interested in whether or not these things match up. Question mark. That is sine of 0.1k equals sine of 0.1m. Sine of 0.2k equals sine of 0.2m, and so on forever. And I suppose it feels a bit like if these things differ, we know when two sine waves are the same, right? Oh, but not for a particular value, right? We know that there's some rule here about the differences. Probably several things that we could do. And then maybe if we're lucky, everything's all right from there. So to start off with, first idea, see what happens if 0.1k minus 0.1m is a multiple of 2 pi. More and more integers for this problem, for some integer n. Would that be a thing? So it's not a thing, is it? Because it's not a thing because this doesn't happen. Because 0.1k minus 0.1m divided by 2n is rational. So it's not going to be pi, but maybe you can do a good impression of this. And a similar problem happens, you know, unless big N is 0 and the difference there is 0, so we're looking at the same points. So I think what we might be visualizing is rational approximations to pi, hence all the kind of 3.14 stuff going on in chat. You can get some good rational approximations using continued fractions. If I redo this problem so that 0.1 is actually chosen to be some multiple of pi, then you're doing a kind of frequency that is a multiple of the no, your sampling frequency is a multiple of the underlying sine frequency. Mary, I forgot you had a twin sister. You've mentioned that before, I think. I can't remember this, whether wearing glasses has a genetic component or whether it's just a nature thing. Whether it's just a kind of gradual damage to my eyes from looking at stuff. I actually have no idea whether... I suppose there's lots of reasons you might wear glasses. So we need to be more specific if we're claiming this is genetic link. Ooh, Boom and Will says Ben's box. who's been running the Talking Matter in Public conference, or not officially on the committee, I think he said, but he has been doing a lot of stuff on the Talking Matter in Public conference earlier this week. It's been a cool GeoGebra thing, so far not surprising. BEM Sparks makes cool GeoGebra things for everything. Approximations to pi of flowers. He puts those on the web, doesn't he? Let's see if we can find that. Boom and Will, that sounds interesting enough that I'm going to stop what I'm doing and go and look for that. Approximations to pi flowers. What are we even doing? Oh, I don't really know. Ooh, it's a number file video, so I'm not going to do that. Can I find it on? No. Yes. No. Right. Okay. I've got a video. Oh, it's this spiral thing. Is it this? No. Is this a random factoid? I've drawn these on the stream before and in a talk or something. This is a good idea. What sort of spirals are these? Are they Archimedean spirals? I'm not sure. This is just, I've now found a list of all of Ben Sparks' videos. Which one are we supposed to watch? Probably this one. But really, I was hoping to find somewhere on Ben Sparks' website. I think there's a GeoGebra page somewhere. Let's see if we can find that. I think Ben has released. There we go, found it. Oh, I've got to accept cookies. I'll just agree to these ones. Right. Let's see if we can find cool things with spirals. This one's very good. Might be the golden ratio instead of pi. Okay. Not that spiral one, I think. Animations. We've been on Ben Sparks' page before, haven't we, on this stream? Batman. Where are we going? Some Squares 3D demo. So what we're looking for something that we saw on number file. There it is. Is it this? Is it this? Yes. I would like this. It's not flat spiral. Can't I this? Show lyrics. Ooh, okay, what's going on? Oh, there we go. Okay, so it's this spiral generator, which goes round and round and round through different values of R. And reveals itself to be lots and lots of points. I've made one of these before, and I keep forgetting how it works. This one's very good, though. That's a lot of points. Some of them appear to be going backwards. Oh, good. I love things like this. How do these work? I think so. You're looking at lots of points that are rotating at different rates. I can't remember the rule for the rates. It might be linear. Might not be. It's one of those things which, after a long time, gets back to where it started. I think. Depends how you set it up, actually. I've made a version that perfectly loops before, which did something like this. But oh, this is really good. It will also tend to, there it goes, form these kind of spiral galaxy arms. I don't know if you spot there, it happened again. To understand those, you need to know precisely how it's been set up. So maybe I should go back and actually watch the video. Oh, this is a really good version of this. My version had about 60 points when I made one. Oh, good. We've done this in Desmos, I think. There's different ways to do it. Should we have a go? What's this X for? I wonder, I'm pointing at things. Good. So we're we're not very far through here, are we? Let's just go. Okay, so there's some good moments for forming this kind of 5-pointed stars and 4-pointed stars and however many pointed star that is. 8? 7. 286. And 3 about 1/3 and halfway through. Okay, this is definitely the same as the one that I made. Is it? Oh, let's work it out. Go to there. 496. So this lovely moment in the middle. Yeah, it is going to do that. There it goes. Halfway through it gets to the halfway point. How do I do this? and then out the other side. And then it should all wrap itself back out again at the end. So 994, and then yes, one of those ones that does it perfectly back again. Pop. And it's going back down again. Good. Right. Math 222 has had time to try and do a Desmos version of this, which we can have a look at. Can I see this? Oh no, this is something else. This is the sine waves. How many of your graphs are named Cool Graph? I feel like I've seen you name a graph Cool Graph before. Right, let's try and do a Desmos version of the thing we were just looking at. Let's try not to click on like work email or something. I think it would get me to do a login, but you never know. Before I've seen this by messing around with like polar coordinates. I'm just going to change the grid like this. So what was I doing before? So I think if you have some linear thing like this, for some large value of a, I love a, small value of a? Yeah, okay, something like this. Something like this with a very small, so maybe it's theta over a, with a something like 100. Yeah, something like that. Okay, but this has a problem that I need an enormous number, or an enormous amount of graph. Okay, we can solve that. And then you get this, oh no, horrible spiraling thing. I think again we want to sample this at particular points. How do I do that? Well, I guess I put in the sort of sequence of points that I was using before, except now I've been lazy. I've already used my favourite letter, A. I guess I'll use B. So we can sample this. I think I want to do something like so something like minus 10 to 10 again. Got 10. Let's try doing. I regret this. I'm going to call them theta. I'm going to be a bit more professional. Call it theta subscript 1 or something. And then, ooh, how do I do this? How do I do this? Because I want this to be angles, but I only know how to do angles like this. Struggling. What am I doing? I'd quite like these values to be the values that I look at for my graph, so that I have something a bit like the animation we were watching, just to check it is this. I think it's this. Different values of A, right? But evaluated at particular values of theta 1. Maybe I just have to split it into components. That's a little bit inelegant, but I think it works. So if I just do components like this, cos theta 1, trying to use backslash theta 1. So we might r cos theta, r sin theta. I think this is how I'm going to tell it that I'm using polar coordinates, and I regret all of that. I'm just going to go from 0. All of that. Okay, so now I've got some points, and as I change A, good, they're on the red line. So I did my sine and cosine correctly. But what do I want here? Yeah, so I want these to be fixed radiuses, but change this frequency like this. So I want something like this, don't I? Right, I scale, but they stay within that circle, so that as I change A, they just go round and round. There we go, good. I think we've seen this before. Okay, got there in the end. Let's do loads of them, because we just saw loads of them. Let's turn off the grid. Don't think we need that, and the axes. There we go. Here's we saw a cool thing, and I wanted to make the cool thing. We've now got a version of the cool thing. Off it goes. It goes round and round, and it reveals that it's made of dots, and some of them appear to be going backwards. Hooray! Right, okay, Desmos. But the thing about Desmos is now it gets to analysing it and working out what's going on. In particular, there we go. So you get these spirals in it. Lovely. Got there. Good. all of that was basically so that I could say, yes, it is an Archimedean spiral. I thought it looked like an Archimedean spiral, rather than just watching the video. RFL, you know, we got there. It is going to make us feel ill if we look at it for too long. Let's not do that. Maybe I should work out how. Okay, I'm not certain I've made the right thing yet. I suppose I'm interested in what happens if this is pi. Does that get me? Does that do anything interesting? Not really. The one in the video got all the way round. It had some sort of point where everything was round again. Let's think. When does that happen for mine? So mine are every 0.01. So if that multiple, the very first one, had done an entire loop, so if A were 100 pi, then it's getting 14159, then it gets back round again. But you need loads of decimal places. Okay, so this gets round after 100 pi. There's a use of 100 pi. 314, still a good number. Deserves its Wikipedia page, I think. Because I've got this small gap in the radius for where the dots are, and I want the innermost one to have done one loop. Okay, so then it just scales. The next one has done 2 loops, the one after that's done 3. So if you like, this is another sort of thing. And maybe this is why Boom Man Will brought it up. It's another sort of thing where after this whole animation, to get to 314.159, after this whole animation, the points have all been on lots of journey. There's some things that are doing really fast rotations, but at this moment of sampling, 3.14159, at that moment of sampling, they've all got back a certain number of rotations. So it's as if they weren't moving at all at that moment. Kind of a link back to the sampling idea. It should be 2, shouldn't it? The halfway point. It's not 2. The rule for the number of arms is something like. Should we put the factor of pi in? If I put the factor of pi in here and here, then if I put the factor of pi in, then it moves the problem to not being in the slider, but being sort of kind of like there's a factor of pi down here, which kind of takes the fun away, right? Because we had now it's just a percentage bar, isn't it, out of 100. Get back. But this lets me do things like say what's going on at 50. It's not quite what I expected to see at 50. I've been saying pi. I should have been saying 2 pi all along. 2 pi. Oh no, not just 2 over there. There we go. 2 pi. And that gets me around. There we go. Okay, so now it's back to where it started. It started like that, and it ended like that. Right, so now the 50 point is halfway point where it's like that. 49.5, 6, 7, 8, 9, 50. Okay, and some other interesting points along the way. Ooh, that takes a lot of 3s. Around here. And then, so there's something going on at 61.8, which is something, okay. So then the video, if we go and watch it, is going to have to be about that, because that's lovely. And that looks quite a lot like a sunflower. And it's like the kind of golden ratio sunflower thing that people talk about, maybe. Right, okay. Multiply by 100. Or, yeah, maybe I should multiply by, yeah, okay. So I put two zeros in here. Get some really nasty shapes in there. Then this is a sort of 1 over phi thing. Or phi minus 1 if you prefer. That one does look good. So, can I remember this? Short of going and watching the number file video, which obviously I should go and do. Can I remember what's nice about this? Not really. I mean, it spirals in both ways, but you can also say that for... to pick a random number, right? Like, what's a funny number? Oh, now I've said that I shouldn't do a funny number. I mean, that's kind of spiraling both ways. What point am I trying to make? This 788 thing, it's kind of got that going on in the middle, maybe? Maybe not. Oh, do not scroll on this. Scrolling on this produces the same effect as spinning it, which is that's not actually true. That's a logarithmic spiral fact. The logarithmic spirals are the ones where zooming does precisely the same thing as rotating it. This one, though, is still a bit unnerving. That's kind of cool, actually. I don't know. I never know. I never know. What's more cool? Something that stays the same as you zoom, like a fractal. You zoom in and it's still the same. Or something that has kind of interesting detail on the small scale, so that's different from the details you see on the outside. So here I see these spirals on the outside, and I see a kind of sunflower thing on the inside, and I'm kind of like, oh, it's nice that it reduces both. Whereas if it were a fractal, I would be saying, oh, it's nice that it's the same. Am I just easily impressed by things that are either this way or that? Whatever happens, I love it. It is the number where the continued fraction converges slowest, but obviously if you're going to bring that in, you need to say something about why continued fractions are related to this and why convergence is related to this. It's a true fact about golden ratio. You know, if I say it's root 5 plus 1 all over 2, then it's obvious what root 5's got to do with it, or dividing by 2. But, you know, all these true facts about golden ratios, but still not related. Anyway, I think I'm going to have to leave you to watch a video. That's very good. Right, okay. Once again, thanks to Ben Sparks for making a thing. This is often the thing we say. It's good. Right, okay. What are we doing next? I can tell you this puzzle. As I was setting up the puzzle, I realised the act of setting it up for the stream made me realise that I'd seen it before. I'd been thinking about it before, ages ago. I'd been thinking about the puzzle. I mean, Stark, but then just making the props gave me enough time or a different framing to make me realise that I'd seen it somewhere else. So that's the whole thing. It's a puzzle that someone showed me yesterday that's made me think a lot. And it's also got the format, you'll be pleased to know, of a puzzle that has a nice answer that we've seen. So I see what you mean. So fractions look good. 0.618 is nothing like a fraction. It's the most irrational, so it looks bad. Okay, I'll give you that. Okay, I guess that is like a do I want to play with this math? This website in chat that says it's a Canadian website that says math test. I'm going to load it on my other monitor just to find out what's going on. Let me give you this puzzle and then take a tea break because I'm out of tea. It works like this. You've got some cards. You put one on the table from the top of this is like a pile of cards. That's the top. You put the top one on the table. You move the next one to the bottom of the pile. You put one on the table, on top of that one. You move the next one to the bottom. You put one on the table, you move, hang on a second, you move the next one to the back. You put one on the table, you put the next card on the back. You put one on the table, you put the next card on the back. You put one on the table, you put the next one on the back. You put one on the table, you put the next one on the back, and now it's interesting because I've gone round all the way around. This game is not just odd numbers only. You put the next one on the table, you put one on the back. You put one on the table, you put the next one on the back. You put one on the table, if I've done this right, I think I'm doing this right. You put the next one on the back. You put one on the table, right, I'm going to shuffle that way, this way. Where was I? I was about to put this one on the table, and that one on the back. You put that one on the table, you put that one on the back, and then you put that one on the table. And the question is, which number are you left with? We're left with 10, so in general, not just 13. Thank you for tea. Not just 13. Which card is last? So you can tell me don't do it straight away if you've already spotted. Give me a second. I'm going to take a tea break. I'm going to go and make some more tea. You're welcome to think about this. Maybe try and find some cards if you want to play along at home. It's 13 because that's how many you get of a suit in a pack of cards. we're going to change that number and play around with it. Or if you've seen this before somewhere with a different description but the same process. If you've seen this puzzle before with a different outfit, see if you can remember where you've seen it before. It's possible you've met this before. Right, okay. Thank you, Mary, for redeeming tea time with channel points, which means that we will take a break and make a cup of tea. I'm going to be back in a couple of minutes with a cup of tea. You've got a puzzle to think about. You could go and make a cup of tea. You could grab a glass of water. You could go and find some cards. Because I think I want to talk about this just a little bit. Just a little bit. It's got a link to the other one we were doing as well. Right, no, I really do need to do the tea break. That's not quite the button I thought it was going to be. I'm just going to change that button. Sorry, I've reset the. I had a very short conversation with Cat Does Maths, who's a Twitch streamer who does maths. And they gave me some advice about setting up Twitch, which I am now going to try and do by running an ad break. They've told me how to set up Twitch controls in OBS, which is the thing that everyone uses, but apparently I can put my Twitch controls in there as well, which is life-changing because now I don't need to separately have a window for Twitch. And something you'll know if you've seen the stream before is I get very confused by having multiple windows up for OBS and Twitch and all of the kind of multiple control panels. Apparently you can just have one thing. That's how everyone else does it. Thanks, Cat Does Maths, if you're watching. Right, okay. Yeah, right, tea break. Let's do the tea break. Back here in a couple of minutes. See you. If you see an ad, you're supporting charity. That's what we always say. Right. I think I'm back. What is going on in Twitch chat? Is everyone behaving? Mary's gonna have breakfast. Yeah, Meme Machine Rex. There's a system we've got where you get ads at the start, you get ads in the middle, and if you hang around after the end, I bet you get ads then as well. Sorry. Anybody in chat want to put something in for, well, either what's going on here, or have you seen this problem before? That's not quite the same thing, is it? I'm going to reset it. Maybe I'll take. Yeah, how am I going to do this? So actually, I'm going to do a little screenshot of this to say this is the problem. That's not a good statement of the problem, is it? But let's have the screenshot anyway. Oh, now I want to line up the grid squares. There we go. Okay, statement of the problem. We got these numbers. That's not a problem statement at all. I haven't described the whole remove every other one part of it. Time for a sort of reveal of, while I was making this set of cards, I realised where I'd seen this before. Well, so I don't know the answer. I'll explain in a second. I'm pretty sure it has a nice answer, but I'll explain. So a different version of this problem works like this. You've got some things in a circle, and you eliminate every other one. And once you've been round, you keep going every other one that's survived so far. So you eliminate 1, and you skip 2, and you eliminate 3, and then 5, and then 7, and then 9. I really hope this gives the same answer. Oh my goodness. You skip 2, and then you eliminate 4, you skip 6, you eliminate 8, you skip 10, you eliminate 12, you skip 2, you eliminate 6, you skip 10, you eliminate 2, and then 10 is the last one left. Okay, I think I did that right. Let's rewind it. Let's replay round. One more go just to check. 1, 3, 5, 7, 9, 11, 13. Skip 2, 4, skip 6, 8, skip 10, 12, skip 2, 6, skip 10, 2, 10. Good. The 10 is left. Aha! Yeah, like musical chairs, right? The people sitting in chairs. The name for this problem is the Josephus problem, and it has a kind of gory setting that is occasionally presented to children as these people that like a kind of, they're words I'm not allowed to say on Twitch. Let's find out. These people have a sword and they're all gonna die except for one survivor in a kind of horrible ritualistic process involving passing the sword around and slaying the person to your left. And that's a setting for this maths problem that has been used with children. To say the setting is something about Josephus. I can't remember who that is, but there's some sort of historical setting for it as well. So you kind of start by suggesting that this really happened or something. You say, hey, these people are all gonna. It's just awful in a way, isn't it? So when Mean Machine Rex says, I've done this in kindergarten, I'm thinking, oh, I hope not. Anyway, that's the problem that I've seen before. And I'm pretty sure there's a 2 to the n thing going on. So there's a conjecture in chat. Yeah, I know that TikTok is like that. And I realised at the start of my gory anecdote that I couldn't remember if Twitch was like that as well. If I'm now banned from Twitch, then it was fun. Mostly. Okay. So suggestion in chat that we try this with a power of 2. I'm going to try it with the smallest power of 2 I can be bothered to work with. That's not true. I've been bothered to work with smaller powers of 2 before. Let's get out my red marker. So if I eliminate the odd numbers first, and then I skip 4, eliminate 2. Haha, 4 wins that version. Should we check the 8th version as well? Hey, thanks for the... What is that? I've hidden the window that tells me what that says. Thank you, Rua3001? Hey. Yeah, you're helping us with the goal that we remembered. We set a goal ages ago, forgot about it. It just became part of the overlay. You're helping. Right, okay. So Josephus problem. We're going to try it with a power of 2 because we think that's nice. So I'm just going to take those ones. The reason I think this has a nice answer is that someone I know does this as a masterclass with kids, and they no longer do the kind of gory setting for it. They tell the kids something else is going on with people sitting in a circle. So skip the 8, eliminate 2, skip the 4, eliminate 6, skip the 8, eliminate 4. So it's really looking like if you have a power of 2, then you kind of saw it happening as well, right? We eliminate the odd numbers, and then the numbers like... What did we do next? We eliminated the odd numbers, and then we eliminated 2 and 6. So they're not odd, but after you divide by 2, they are odd. Something going on there. So because we have a power of 2 in this version, after you've eliminated the odd numbers, you're left with even numbers. So you can sort of relabel. You can sort of say 1, 2, 3, 4 is kind of where we are. And the count passes so that the next thing we're about to do is eliminate 1. And then you've got the version with 4. So by induction, it's the last thing in all of these cases. Okay, very nice. Right, okay. Aha, there you go. F of 2n is f of, or 2f of n or something. Yes, good. Okay, which is a little bit like one of those functional equation relations, right? But just for 2. The master class is called the power of 2, and I think the punchline is about binary. But I've never actually seen the whole thing, so I don't know the punchline in terms of binary. But I think what we're supposed to do is something like look at the binary representations of these. So I'm trying with 10 at the moment. Let's see, so 10 is even. Let's just see what happens. And obviously the place we're going with this is we're going to try and make a graph of n along the x-axis and last one standing along the y-axis, because I suspect that it has a kind of Sierpinski triangle shape to it, which was going to be good. I haven't got 34 cards though, right? Maybe we'll try 34 if I can be bothered to draw that many cards, right? So if I eliminate like this, then because 10 is even, I'm about to start eliminating here. So I kind of want to do the relabeling trick again, but now I'm looking at 1, 2, 3, 4, 5, and I don't know who wins that game. So I think, yeah, okay. But it's still the functional equation in chat or something, isn't it? That f of 2n is 2f of n, because whoever wins this, we're about to pass the crossing out. The first thing is about to be crossed out because we skipped 10, and now we're looking here. I'm about to do the crossing out. So what's this going to do? It's going to eliminate 1, which is just like the problem with 5. Okay, so f of 2n really is 2f of n. So if I make 34 cards, then the first thing we do is eliminate 17 of them, and then we get perfectly back to being about to eliminate card number 2, which under my relabeling in green would be card number 1. So we'd be playing the game with 17 remaining cards, we might as well number them 1 to 17 because we're about to eliminate 1. There's a difference, isn't there? If we have an odd number of cards. So have I defaced my cards? Let's find out. Every time I've been undoing because I don't know if I'm drawing on the cards or not. Occasionally with Myro you draw and the drawing is on the card. Oh no, that was the card, not the drawing. I think I've got away with it. Not defaced any cards. Okay, so we need a rule for odd numbers as well. Let's try 9. So 9 is going to be a bit different because what happens with 9? So I do the crossing out for the odd numbers, and now it's a bit different because I'm about to skip 2 and eliminate this thing here. So I could renumber. I've got 4 things remaining, but I'm about to eliminate 2 instead of 1. Which I suppose means that the... Oh my goodness, right, okay, so... Oh, have I been censored in some sense? Ah. Have I been flagged 18 plus? Has that just happened? No. Surely not. Amazing. We start talking about Josephus and we find out that that's for 18 plus. I will report that back to the person who does this with small children. Okay. I think we're about to discover. So we're about to go and cross out 2. So what does that mean? Well, it means that we shouldn't really put the green 1 here. Green is the value of... So we've got numbers 1 to 4. And we're looking at a case with 2n plus 1. 2n plus 1, where in the picture, n is 4. And the question is, do you want to do the same thing that you would do with 4, but just double it? Or would you rather do something else? I think what you want to do is not do that, because you're about to eliminate 2 rather than starting with 1. Does that mean it's just rotated by 1? I think that means it's just rotated by 1. So whatever is going on, everything, the first bit of elimination is going to start here. So I think we're going to find, so eliminate, skip, wins, which is sort of plus 2 or plus 1. Ooh, yuck. Okay, so that's not very good. So the winning number, instead of being 4 that time in green, was actually 1 because everything was rotated by 1. So what do I want? I want something like... If we get a rule for this, by the way, we're kind of done, because then we've got rules to generate all of these. I think I want a different example. Because yeah, there's a mod. I'm gonna do a mod. I don't want to do a mod. I think it might be mod n, because here in my picture n is 4, and I think I want to do a mod 4 to explain how to get back again. Oh, not with the big marker. And am I supposed to double it again at the end? I think I might be supposed to double it to get back to the correct starting number. So I think I'm going to double. Definitely even, isn't it? Oh gosh, I hope they're all right. Gosh. Oh, right, okay. Right. So I want to add 1. No. Add 1. Oh, I see. There's an extended bit. I missed most of the bits. We're back. We're back. Okay. I think it's mod n, not n plus 1. How does Maths2 is ahead of me and has made a Desmos, but I'm not opening the Desmos until we agree on whether it's mod n or mod. Yes. Oh, and you've got a 2. You've moved the 2 inside the brackets, so your mod is going to be different from mine. Maybe it's all fine. I think in these pictures, in this picture n is 4 because my 2n plus 1 is this 9 thing. Could check it, right? Because then I'm claiming e.g. f of 9 is 2 times, and then mod f of 4 is 4. Skip, f of 4 is 4. So f of 4 is 4, so this is mod 5, 4 is 1, is 2 times 1, I think. So I think, I know, it's irritating, isn't it? I get annoyed too sometimes, especially for work. We worked out for work, occasionally we get trolls, or like well-meaning trolls, or quite subtle trolls on the Matt live stream. I think it's really hard to tell, and that's how it works, I suppose. Really subtle trolls, and it always works, 100%. because that live stream has to answer people's questions. So the sort of trolling where someone asks a question but not for real is very effective. We had this a couple of weeks ago, I think. You never really know, right? It could just be someone with questions. 7, 9, skip the 2, skip the 6, skip the 2. It's 2. I think this is 2. Ah, you mean mod 2n, right, okay. Because you've doubled everything, I think. We should test our theories, right? By trying to make a table of some values of these things and checking them. Because I think I've now got enough to generate this. I'm not looking forward to that because of all the mods. Well, let's find out. So I suppose we could check f of 3, which would be what happens if you have 3 cards. And in this version, you cross out 1, you skip 2, you cross out 3, and then you're done. F of 3 is 2. But the more interesting one is f of 7, and the way that it relates for n equals 3, the way that it relates to f of 3. Let's see if we can get this right. Okay. So eraser for the slashes. 4, 5, 6, 7. Get them in order. 2, 3, 7, 6 here. 5, 4, 3. And then do the crossing out. Experimentation. 1, 3, 5, 7. Now here's the key bit. So there are now 3 cards remaining. They're numbered 1 to 3, doubled. But I'm not crossing out the one numbered 1 first. I'm crossing out the one numbered 2 first. Weird. So I'm going to cross out 4 and 6. No, not 4 and 6. Because the whole point is that you skip 1. Skip 1 and get 6. Equals 6. Check 2 times. And then my rule at the moment, because of the kind of wraparound thing, I've got this mod. Is it mod f of 3 plus 1 mod 3? And maybe you can multiply some of that by 2. But that would be... oh dear, that's 2 times 0. You've done 34 by hand, well done. So my rule has let me down here. Because why was it done? So I think I need this mod function to return something from 1 to n, annoyingly. So they get 2n or something. I've got loads of out by 1 errors. That's a bit annoying. Oh, okay, my mod function for mod n needs to return something from 1 to n. Let's remember that. So that I don't get 0 out of this. I'm about to plug in 2 over here, 3 inside here, mod 3, 3. I mean, it's kind of equally 0 and 3, isn't it? I want to write that as 2 times 3 is 6. Okay, let's do a couple more. And because I think Maths222 in chat is ahead of me and has checked several, I'm going to ask them whether does the thing on my screen agree with the thing that you've got. I mean, I could try 13 now, couldn't I? Let's aim for 13. 13 is 2 times 6. So I've got my rules are quite mad. If it's even, just double f of this. So I predict that f of 6 is 4 and f of 13 is, oh my goodness. So instead of doing 2 times 3, I have to do all of this 2 times and then loads of stuff. And my rule at the moment, I don't love it, but it's this. So to get from 6, 5, comma, and then 6. So that's fine, that's 5, that's 10. Ah, good, and it was 10 before. Aha, right, good. I'm happy now. So I guess what you've done in Desmos is something like one of these recurrence relations, right? Where you have something like f of n is 1 if n is 1, and then a different case for let's do this. Let's just quickly check this. If n is 2, I just want to check I'm going to do cases quickly. 3, and if n is greater than 2, 4. Is that how this works? No, this is the opposite of how this works, apparently. Why is it drawn that backwards? What have I done? What's it drawn? I just want to check I've done cases right. Quick check how Desmos cases work, but I'm going to put it on this monitor. Is that way around? Piecewise function, how do they work? You put the conditions first. Good. So if I have some like large values, 17 or something, lean into it, 34. Plot the points like this. Oh, that's better. Okay. Okay. Ah, colon there. There we go. That's a bit better. So then it goes 1, 2, 4. Okay, good. But I don't actually want this. I want a rule which says if n is greater than 1. I'm gonna have to do some mod stuff to detect if it's odd or even, right? Here we go. Here we go. So what do I want here? Mod n2. What does this return? So this returns 1 or 0. So if it's even, I just want you to return. So mod n to 0, I want you to return the same thing that you would do with f of n over 2. That seems sensible. Okay, so that's filled in some like power of 2 stuff already. Very close. And if 2 times that, sorry. And otherwise, I want you to do some horrible mess, which is my rule there was 2 times mod of f of, and then I've got to do it like this for this one, n minus 1 over 2 to get the kind of recurrence going, comma n, like that. But I wanted to add 1 or something. Have a quick look at Miro. So f of the small thing, f of the small number, there's like minus 1 divided by 2, because to get from 13 I want to get down to 6. Ooh. What's that 5 doing there? That is f of the small thing. That 5 is f of, where's that 5? It's 1 more than f of 6. There we go. So this mod thing here should be 1 more than f of 6. Oh, I've got way too many brackets now. Way too many brackets. How can I have fewer brackets? I've just closed too many brackets over here. Okay. I've really annoyed it with the brackets. Because I'm no longer opening my mod bracket and closing my mod bracket. And now it's unhappy about everything. Live coding, let's go. It's always slightly slower than Twitch chat. I'm gonna do it. Maybe I need to put this in as well. 2 arguments. Okay, I'll put my mod brackets in the wrong place. F of this. Hello, thanks for the follow, Kay Elamabari. We are trying to do some Desmos shenanigans. I've got too many brackets in Desmos, which is, oh my goodness. Oh, what do I want? I want that much for my function. I'm adding 1, and then it wants to do mod. Why is it unhappy with me? Why does it put a ghostly pair of brackets like that? I don't want those brackets, Desmos. Don't do those brackets. Let's put F in here. Oh, there we go. Oh, we fixed it, I think. Let's check things that we know, like f of 13. It's not correct. It's not correct, but it's close. Let's check things that we know, like f of 4. It says 4. I think we saw that. F of 5. It says 6 at the moment, which is not even true. F of n is 2 if n is 1 more than a power of 2. Otherwise, it's f of n minus 1 plus 2. That sounds pretty good, doesn't it? Does my mod thing just simplify? Does it always loop around like that? No, surely not. Ooh. What am I doing? Well, I failed to type this in correctly, haven't I? Failed to type this into Desmos correctly. I have typed it incorrectly. What am I trying to do? If it's even, I just want to divide by 2, multiply by 2. Cases. Maybe if I put in this mod n to just 1. Okay, I won't do this. Nope, still unhappy. What's the smallest case I can check? So it's not even returning a number in the right range at the moment. If 2 is 1 because you eliminate the odd numbers. This should be 2. So this is the first case where it fails. And I think it fails because it goes into this last case. So n is not 1, it's not even. It goes into this last case, which I'm having trouble typing. And the correct answer in this case is you eliminate 1 and 3. So the correct answer is 2. It should be 2 times this. So why is this f of 3 minus 1? Do I believe this? 3. And that's returning 2 already. Because it's calculating f of 1, which is 1, it's adding 1 and getting 2. And then that's also being multiplied by 2. So it's returning 4. No. That's too large somehow. Why is that too large? Why is that too large? So you eliminate the odd numbers. Thank you, chat. Right, yeah, the N on my Miro is different. Thank you. You used a celebration in chat for that. Amazing. Thank you. The N on my Miro board is different from the N on here. I fixed it there, but not on the other one. Thank you. I was almost there. All right, maybe it shouldn't be 3. It should be mod 1 or something. This is now returning 0, which is not great, but you know. How can I fix that? I think we interpret 0 to be the same thing as n. Maybe? That feels wonky. Don't like that at all. No, yeah, that feels wrong. Oh dear. Not a good day. Look, it's returning 0. Yeah, do that. Does that work? That does work. Thank you. So don't add 1 inside this mod, you mean? Add it over here. Plus 2 on the end. That does look a bit better. So it's now returning f of 3 is 2, which is correct. F of 4 is 4, which is correct. F of 5 is 2, which I have to think about. 1 through 5, and then 2 lives. It's returning, is this going to be 10? If this is 10, we're good. I think we're good. Thank you, Math222 in chat. I think you fixed it. It's even agreeing with F of 34. Okay, cool. So other than the mod being out because of my transcription and needing to fix it to be in the correct range, I was almost there. Great, okay. Right, and time for a plot. That is not the simplicity triangle I thought it might have been. That is way better. So this one point here, where being person number 1 is usually terrible because you're the first one to be crossed out. But there you go. Let's go higher. Okay. There you go. Steeper and steeper slopes. No, wait. What is this? What is going on? So other than the first dot, it's doing this slope of particular gradient again and again and again. That's brilliant. So then you start to wonder whether there's a simple answer, right? So this is the answer to, if you do this card process, what's the last card? And it's starting to look a lot like, there was a simple guess in chat, right? Just something like, what is this then? So 2n, but minus quite a lot. So in decimals, 2x is like that gradient. 2x minus 1 goes through there. 2x minus 3 goes through, it doesn't quite go through those. 2x minus 4? Right, 2x minus 8 goes through those points. 2x minus 16 goes through those ones. So something like, how are we going to phrase this? Where does it jump down? Oh, that's not the right point. That's what that is, 32. So something like 2x minus the largest power of 2. That puts you in range or something. Yeah. So, right, in binary, that's something. In binary, thanks for the binary nudge. these are the ones. So these ones don't have. This is 16 to 32. So these ones. What am I doing? I'm doubling it, which is like writing a 0 on the end, and I'm subtracting the next power up, which would be taking the 1 off the front that you get. So something like the process, and we haven't proved this yet, but something like the process goes, you have a number like 13 in base 10 is, goodness me, what is it in base 10? Base 2, so it's 8, 4, no 2s and a 1, and the rule is something like remove the 1 from the front and put a 0 on the end, and that is an 8 and a 2 is 10 in base 10. I should use a different colour for base 10 or something. So that 10, the answer that we got. And 34, our standard large number, is 32, no 16s, no 8s, no 4s, a 2 and a 0. And then if you take the 1 off the front and put a 0 on the end, you get 4, 4, which is the answer for that one as well. On screen I can see f of 6, so 6 is 4, 2, 0. Take the 1 off the front, put a 0 on the end, and that is 4, which is what we got. 4 again. Hey KA10, welcome to chat. -1 and take the highest power of 2. You take -1 and log of 2 floored, 1101. Right. Okay. Except for powers of 2, which is different. Good to see you again, KA10. How are you doing? Right, we've got to prove that. That's great. That something like the rule is always 2x, but there's all this modulo wrapping around stuff. So you're really just doubling the number, but also, no, not quite wrapping around. You're taking away a huge power of 2 as well. That's what I'm doing, right? So when I'm doubling it by putting a 0 on the end, but also taking away this huge power of 2, this 1 on the front. Take off the 1 on the front, put a 0 on the end. Yes, this highest power of 2 thing is a bit awful, isn't it? Maybe I am happy with this. How would I phrase that? As a closed form expression, I would do something mad with logarithms, right? Like you're saying in chat, KA10, log base 2 floored or something, which, yuck. Oh, and there's still an exception for powers of 2, because if you take a power of 2, if you do this to a power of 2, powers of 2 are interesting in binary, because a power of 2 in binary just looks like this with lots of zeros. So if you do this process of take the 1 off the front, put a 0 on the end, then you just get the number 0, which in the kind of modular arithmetic world, we're interpreting that as being the same thing as the last person. We've numbered them from 1. I sort of think maybe we should have numbered them from 0, because of all that I got messed up by some modular arithmetic stuff in the middle. Maybe if we number them from 0, then the interesting case is if there's a power of 2 of them. So then maybe I can cheat by talking about the last number or talking about how many there are separately. Whoa. Have you just posted the same formula as each other in chat simultaneously? That is kind of amazing. That is amazing. There you go. Look at them go. Except power. Yeah. Amazing. Right, so I think that's the problem then. I kind of a bit care about the other numbers along the way, but I think we've answered what's going on. I haven't proved that this horrible recursion thing has the nice simple answer. I can kind of believe it. The cases to check here are something like if this, okay, no, tricky, not cases. Yeah, it's going to be a mess, isn't it? It's almost doubling. But there's some mod in the way, which stops you from just adding. So it's not just what you want it to be. Also, it's +2 on the end. If you ignore the mod, it's 2 times fn plus 2, which doesn't feel right. Maybe that's consistent. You're doubling n plus 1. So if I'm doing some sort of induction thing, then 2n plus 1 means you write a 1 on the end. And my whole plan is to write another 0 on the end. So is that really what's going on? Yeah, it's +2 compared to what would have happened if it was just n. Okay, I think I'm sort of happy. I don't think I want to chase through all of the mods, what's going on, especially because I'm feeling bruised on the modular arithmetic front, having messed one up putting it into decimals. Oh, is there a BMO2 problem that's like this? Let's load it up, just put it on screen. I don't think I'm going to do it. He says as if he could do it. Problem 3. Ooh, I found a Stack Exchange. Let's have a look. Was I in school in 2011? No, I wasn't. I have not done this at all. Whee! It's on screen. It's a functional thing. Okay. So recommendation. So many rules. Oh, is it the same? If n is even, as follows: f of 1 is 1, f of 2n is f of n if n is even, f of 2n is 2n f of n if n is odd, and then so many more. If you had an even number, and then, okay. So is this one going to be some joke about binary as well, right? Possibly. So what does this say for binary numbers? Something like, I'm now primed to think about binary because of the right thing for the previous question we were just looking at. Maths 222 wanted to look at this. Let me try and reason about it very quickly. So if you double, then if it ends in a 0, then writing another 0 doesn't change anything. So you can write lots of zeros. Once you've got a 0, you can write more zeros and nothing changes. But if you write a 0 after, a 1, if it ended in 1, if it was odd, and then you write a 0, ooh, that's when you multiply, the function gets multiplied by 2. Okay, so if the last digit changes from 0 to 1, I think it's going to be detecting edges. It just feels like this pattern is going to be 2's in the other place now. Yeah, I get it right. So then if n is even, if it ends in 0, and then you do this, then the last digit you're changing from 0 to 1, and it doubles. Oh, and +1. Yuck. Okay, +1. Right. Okay, fine. It's not just counting. It's not just counting changes. What's that going to do then? Oh, this is really good, isn't it? So something like you have a string of 1s and 0s coming in, and as your string changes from 1 to 0, that gets detected, and we shift the value. There's also this doubling and adding going on in the function value. So it gets doubled. We write a 0 on the end every time we see that, and then we write a 1 if it switches back to a 1 on the end. We write 1 on our number, and then so if it ends in 1, then if n ends in 1 in binary, and you write another 1 on the end, then I don't care. Okay, so this function takes your binary number and reduces each string down to just a single instance, right? Because if you have lots of 1s, the first one triggers this thing, write a 1 on the end, and then all the additional ones don't change it. And if it's got a 0 on the end, well, if you write a 0, after a 0, nothing changes. If you write a 0, it's really good. If you write a 0 on the end of something. So after a 1, if you write a 0, that's your first 0 in a string. So you now have 2n, and the target gets doubled. You write a 0 on the target. So you process, as you're processing, you read your number n from left to right, and sometimes you write down the digits and sometimes you don't. based on whether it's changed. So that 2n plus 1 means you write down 1 on the end of the number. So your answer is going to be something like 10101001, I think, with some length. Like how many strings of 1s and 0s. And it's going to have, we'll ask for f of 2011. So we're supposed to run this process on 2011, get some string of 1s and 0s, 10101001, and then decide how many places there are to put the 1s and 0s back in, put extra 1s and 0s back in, which is sort of combinatorics puzzle, isn't it? You can choose, you have, oh dear, no, you've got a limit on how long the number can be, but I think that's it. Oh, less than 2011. I'll have to think about that. Maybe less than 2011, so you can put extra 1s at the front. You're going to sort of augment the number back out again to get something which could be confused with 2011 after you reduce each string of 0s or 1s to a single 0, 1. That's brilliant. That's really good. I like that a lot. I think I can do this question. I don't think I've got a write-up. I don't think I've got all the bits, but I think I've had enough ideas now. In particular the bit where we realised that that's not actually that scary. That just means write a 1 on the end. That's so nice. Right, okay. The end is odd, so it ends in 1, you do this, you put a 0 on the end of the target thing. Value. So it's always going to do... Yeah, okay. So you don't lose any strings, they just all become a single 1 or a single 0. So now I think I need to, if I'm going to do that, I need to convert 2011 to binary. I feel like doing it now. Oh, is this something everyone knew in 2011, how to convert 2011 into binary? Oh, I don't know. What is it? So I'm going to have to do so much subtraction. That's the only way I can think of how to actually convert this. Is that nice? That's not that nice, is it? Because it's slightly less than 2048. Everyone knows. Yeah. Thanks, Barry. I'm glad. You like 2025. You know as well, right? 2048. I don't know. What is this? Being reduced to subtracting a large number from a small number. Everyone help. Everyone help. I'm going to do it the slow way, and everyone can be very, very proud of me when I get to an answer. Oh my goodness, 200 take away 102. I'm going to carry like I'm in primary school. Let's go. 8, 9. That better be true. I think I've got away with it. And then 987. I think just embarrassment of being like, I need to do all the carries. I need to do all the, including the double carry thing. I cannot do it faster in my head. But maybe that's good for me to not try and do the faster carry thing. Oh, this is going to be not very many 1s and 0s, I think, because we've got 1-1 already. This is going to be good. Let's go. Confidence, you're right. Or at least willing to make mistakes. 219, that's quite good. So now we're going to get a 0 because we have no... Oh, no, it's got loads of... This is good because there's lots of 1s at the front. So we're looking for something which doesn't have that many... Ooh, it's going to have fewer 1s at the start in order to be smaller than 2011. Have a 0 sooner. And then anything goes. That's a really good question. Okay, 91, but then 91, is it all 1s? No, surely not. That would be stupid. It's odd, so it's going to get back to a 1. 64. Oh, okay, fun. I'm saying stupid stuff, and I'm calculating subtracting. 27. So then no 32s, and then a 16, and then I've got 11 to go. Look at me. I'm trying to show off now. I can subtract small numbers. No 4s. 2 and a 1, I think. Let's check. 3, 11. 3 place value. 3, 11, 27. So me, isn't it? 64 on one of those. I want one of those. 128. I want a 256. 1512, and I want a 1024. Quick check. So add easier way. Add 34 to get 2048. 35, right? 30, no, 36. Numbers. What do you add to get to 2048? You add 37. My favourite number. Yeah, so you add 32, a 34 more, and a 1 on the end to carry over. And that would be 36, 37 to get to 2048. Good, right, okay. And now I check with KA10 in chat. He's done that much better than me. 5 ones, a 0, 2 ones, a 0, 2 ones. Google it. Right, gosh. Oh my goodness. Okay. And KA10 also said that in chat ages ago. Thank you. Good thing I wasn't looking at chat. I should have set chat to like emote only or something so that I could do my binary subtractions really, really fast. Anyway, my prediction is that f of 2011 is just quick check. So 10101 in binary. That it'll strip out all the additional ones and zeros from each string if consecutive ones or zeros. 1 plus 4 plus, I've got tired now, 21 or something like that, whatever 10101 is in binary. And then my rule for, so other things like that, other things that give that have some ones, some zeros, at least one, some ones, some zeros, some ones, and then there are some restrictions. So other things that are less than or equal to 2011. Is it less than 2011 in the question? Let's do less than 2011 in the question. Some ones at the start, at most 5. No, don't mean that, because it could have lots of ones and be a small number. This is going to be annoying. Counting problem. Wow is 1 and oh no is 0. And then you can do anything, right? Because then you can encode any channel. You only need 2 emotes, chat. I've given you loads. Just ones and zeros. Just go for it. Let me just link you to a kind of Unicode chart, and then you can send any letter. Brain goes up. If we use brain for 0 and up for 1, we could use stocks up and stocks down, I suppose, to encode our secret messages. Mate, is there a 1 emoji? Probably is a 1 emoji. Just 2 Twitch emotes. And you're like, I wonder what that means. I should decode this. It's a sort of puzzle. And then you decode it and it's a URL. And you go, oh, I should go to this URL. That's how you do phishing scans on Twitch. I'm definitely getting banned, aren't I? Advertising Twitch scams through binary encoded things. Okay, so I'm worried about having too many ones, but maybe that's a fake worry that, I'm worried about some of these numbers being too large, but I think that might be a fake worry because that happens very rarely that you get a number with that. I think I can just limit how many digits there are because I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits. Maximum 11 digits. I could say at most 2047, and that's basically the same. I just need to check some edge cases. Ban some in the range 2011 to 2047 later. Yeah, 11 digits, and you put these 5 buckets. So that's a stars and bars problem. So I think we're basically done. Stars and bars plus some tidying up. Well done. You did find it. Another one. Oh, this is becoming good now. We've got into a theme where there's long enough for BMI1. Oh, so 2007A is a bit before me now, isn't it? Or is it not? Is it when I was in year 11? Did I have a go at BMI1 in 2000? Oh, 2007 I might not have. 2007. Question 6. Well done for Googling that or remembering. This one? No, I don't think I want this one. I've loaded 6, 7, and you wanted 7, 8. 7, 8. Yeah, there we go. Okay, I feel like I've seen this one before. I think I remember this at the top. Can I remember how to do this question? At the top, oh, right, let's get it on screen. So at the top we've got, there's some of some fourth powers, which is fun, and there's some squares down here. And I suppose the only way I'm going to do that, oh, sorry, I've been nerd sniped by this, right? Because this has got to be good. No, that's not good. I should actually scroll this rather than making the window wide. My only guess would be, does this simplify at all? I don't know off the top of my head. What is this? So n plus 1 to the power of 4. But hang on, these are all squares. Why are they squares in the question? Maybe I should write, ooh. Does that matter? Yeah, it does matter. So maybe I should multiply them out. Yeah, so treat 2007 as x, right? And then this is x plus 1, and hope for the best. Quick check to see what happens. I kind of want to know what happens now. So 1x, 1 plus x, powers of 4 upstairs, powers of 2 downstairs. What's going on there? I haven't done this one. If I've done this one, I haven't done it since 2009 or something. What is this? This doesn't look nice at all, though. Yeah, no, I regret this entirely, right? Are we going to find some sort of polynomial divisor of both? Doesn't seem likely. I'm going to keep writing. Doesn't seem likely at all. So it's a factor of 2. That's a good start, I suppose. And then I've got x squared plus x plus 1. So, hard question, is that a factor of the thing upstairs? If not, then I think I'm in trouble. Let's just assume it is and see what happens. So, question, does x to the 4 plus 2x cubed plus 3x squared plus 2x plus 1, actually that does look like it might be a multiple of x squared plus x plus 1. Simplify. Actually that does look like it does, because hang on, isn't that if you have a multiplication grid like this, then you'll get x to the 4, x cubed, yes, x cubed, you'll get exactly these things along there. That's really good. Okay, so it's this thing squared. Yes, it's x squared plus x plus 1. And then you go and remember that x is 2 plus 7, and you go and simplify it. Okay, question 1. Oh, I like BMO. Maybe I like BMO. I didn't really like BMO at the time. What's going on here then? So we've got another function, and this one has been, to fit it on the page, they've really squashed it. Read it in words. Ooh, there's an n in here though. Ooh, okay, this is a bit of a mess. This is a bit different, isn't it? It does the doubling thing, but then it does this. Is weird. What is this? So if you want 2n plus 1, then you'll need to maybe divide by n. F of n plus n. So powers of 2 are what you think. Powers of 2 are fine. Induction. And then what? So proof that it's always an integer. There's two parts of this. Right. So if it's 1 more than a power of 2 and induct like that, how many 1s are in its binary expansion or something? No, I don't like it. So it must be the case that f of n is a multiple of n, I think. Otherwise, what on earth? This bit's not a multiple of n. And I'm trying to divide by n. So is f of n always a multiple of n? It's equal if it's a power of 2, because then f of n is just n. And now try and induct somehow. Induct on, I think we're inducting on the number of 1s or something, and I don't quite see how it's going to work. Ooh. Big AD, that's brilliant. It took me ages, but big AD. What's all these AD numbers? Look, it's 2008. How many times have they got? They've got 2007 here, and 2008 here, and 2007 and 8 here for the 2007/2008 BMO round 1. Question 6 is always really hard. So then the question is, do you understand what integer it is? Is f of n equal to 2n? Or is it twice n? So sometimes it's n, sometimes it's 2n. Maybe I should try dividing both sides by n. Do I want to do that? Not really. Can we try and work out f of 3? So let's take that screenshot of that. Dude. Reset the zoom. Paste the thing in. So what do I want? I want e.g. So this bit's fine. Powers of 2 are what you think. what's going on for this then? So n is 1, right? 1, that was the, this is probably the least interesting thing to plug it in, right? But maybe it'll give me practice. Well, the right hand side really is a multiple of 1, so that's going to be an integer then. Is it 3 times f of 1? So f of 1 really is 1, so this is 3 times 2, which is 6, which is a multiple of 3, so that's nice. So my claim is going to be, I think that f of n is always a multiple of n. I think. It kind of feels like it has to be in order for this fact at the start to be true. And some sort of binary thing going on. Don't love it. Oh, yeah, okay. So f of 2n plus 1 is 2n plus 1 times f of n over n plus 1. So, and then divide. F of 2n plus 1. So look, okay, so writing it like that reveals that if f of n is a multiple of n, then f of 2n plus 1 is a multiple of 2n plus 1. So that's an induction thing. There you go, yes. If fn is a multiple of n, then you get away with it. The actual multiple is going to be relevant. The multiple goes up by 1. So this is going to count the 1s in the binary expansion or something, isn't it? So if you define a new thing like this, it just increments. So let g of n be f of n divided by n. Then what have we got? Our first rule says that g of 2n, so f of 2n divided by so let's take the thing on the left. F of 2n equals 2f of n. Divide both sides by 2n, and you get this f of n over n. So this says something like on the left that's g of 2n because I've got the 2n downstairs, and on the right that's g of n. And then the second one, after dividing, which is the thing that threw me, we have g of 2n plus 1, writing it like this. This is the correct way to rearrange this expression. G of 2n plus 1 is g of n plus 1. So that's counting the ones in the binary expansion. And then we're asked how many numbers less than 2007 have f of n equals 2n, and f of n is 2n precisely when it has 2 1s in its binary expansion. So we're looking for a sum of powers of 2, both of them less than 2048. Maybe ignore some big powers at the end. No, large power of 2. So I'm adding together powers of 2. There's choices for that. Some sort of triangle number for, because you have to choose. The first one could be as large as 1024. Then plus a whole bunch. Because I'm not allowed to. If I have 1024, I'm not allowed to add too much. I'm only allowed to add. I'm allowed to add 512, but I'm not allowed to add. Oh, that's fine. Yeah, cool. Okay, so you're gonna add any 2 powers of 2, large one at most 1024. How many of those are there? That's 2 to the 10, so 11. So I think it's triangle number. These are great. Keep them coming if you can. Well, I'm in the right mood for doing things where the answer is think about it in binary. Counts the ones in n in binary. We want g of n equals 2. 2 ones. I'm going to carry on thinking about that triangle number thing that was in my head for a second there. N is 2 to the m plus 2 to the k, with m greater than k. Could be 0. Could be a plus 1 on the end. Yeah, that's fine. And n is less than 2011 or something in this question. So m is less than or equal to 10, I think. So we have this kind of, I have this triangle in my head, right? Because we have this restriction that on the axes m, k, they're both at most 0, and they're integers, so they lie on this kind of lattice. And the restriction that m is greater than k tells you that you form this kind of triangle-shaped picture. Like this. Except it's not 6, it's 11, because m can be 0 up to 10. How big's a triangle? So, possibilities is, I think, 11 times 12 divided by 2. I really can't remember how big triangles are. I have to think every time. 66. Good. Okay, I think that's close enough. And Math Suited to do in chat is trying to find their favourite one. We've hit 6 o'clock though, so I think I'm going to call it there. Turns out I'm in the mood. I'm quite surprised that I can do BMO questions sometimes. Can I do the other ones? Let's have a look. It's a pleasant thing to find out. Geometry. I never really liked the geometry. Oh gosh. Prove that and then a whole bunch of ratios. Something like Shaver's theorem, isn't there? But that's not what this is, surely. BLLC, CMMA, ANMB. What is this? I through P. This looks like Shaver's theorem. Isn't this Shaver's? No, what does Shaver's theorem say? Shaver's theorem is about the ratios. Parallel. Means BC at L? Like areas or something? That's how you do Shaver's theorem. Wait, what's this subset thing? Okay, I'm not going to think about geometry out loud. 756 distinct numbers. 2 distinct elements. Oh, brilliant. Pigeonhole sort of thing, right? Okay. A and B of S such that A plus B is divisible by A. Mad. Okay. But this BMI 1, so this is something like, this is probably easy. Is it just the obvious thing? So A plus B divisible by 8 means, think about congruence classes. 2008 is a weird number for this, isn't it? Think about the congruence classes. No, 756 can be something like 2008, not quite divided by 8. So congruence classes, there are 8 of them. 0 and 4 are interesting, but the other ones pair up to be numbers that add up to something's divisible by 8. So your challenge, which is going to be impossible, is to put 756 things. Yeah, left to do BMI problems. Nerd sniped by BMI problems, never seen again. Your challenge is to put 756 things into these 8 boxes for the congruence classes on a clock or something. And, oh gosh. No, you've got 756 of them. No, it's not quite just pigeonhole, is it? Because you don't know which ones you've got. You have a limit on how many of each you can have. Okay, it's pigeonhole, but with a kind of maximum thing as well. What? What am I doing? Am I just talking absolute nonsense? So if you put, yeah, there's a maximum on how many you can have. So you might try putting, you can only put one thing in the 0 category, because if you put 2 things in the 0 category, they're both multiples of 8. That's quite bad. You can only put one thing in the multiple of 4 more than multiple of 8 category. So if you put 2 things there, I will add them and get a multiple of 8. So you get kind of 0 and 4 are weird, but then for the 1, 2, 3, 5, 6, 7 categories, you can use 3 of those if you're choosing. Not the opposite ones or something. And there's a size limit because you've only got the numbers 1 to 2008 to play with. So what have you got? 2008 is a multiple of 8. How many of these have you got? But I kind of think you should take off 2 and then divide by 3. No, the size limit is divide by 8. You divide by 8, you get 126 or something. 126, is that right? No, twice that. 251. 251, that is close to 756. Good. Okay, so 756 is interesting because it's 2 plus 3 lots of 251 plus another 1. Six. Yeah, it is. Okay. So you have these 3 cases. You can choose 1s or 7s. But if you give me a single 1 and a 7 mod 8, then I'm going to add them. So you put loads in the 1s or you put loads in the 7s, but you've only got 251 of them. So that's 251 taken. of these numbers that you're going to pick loads of numbers. So, okay, right. Pigeonhole cases, but with a kind of maximum limit by only being able to pick numbers up to 2008. Talking to myself, here we go. Oh, there's 2 triangle questions on this. Circle, oh no. Okay, one day maybe I'll do geometry. Oh, look. Positive integers, these simultaneous equations. Is there a trick? Is there a trick? So presumably it's a trap to just plug one into the other and that gives you a mess. I don't know, that's BMO. So all the x squares and y squares will cancel if you do that, but you'll get loads of cross terms. So are you supposed to multiply? Why not geometry? The geometry, well, I dare say the geometry was the best. Why not geometry? Oh, okay, well, we'll try geometry. Let's try question 3, geometry. It's BMO 1? It's BMO 1. I think it's going to be embarrassing, but I've forgotten circle theorems or something. Or how to draw straight lines. A, B, C. Choose a thing. Let's choose, oh gosh, okay, circumcircle, so I need to draw a big circle. It's BMO 1, maybe it's fine. Maybe this is what I do now, maybe this is the thing I enjoy more than the other maths. It seems unlikely. My geometry streamer suddenly. Hope not. Okay, right, let's move this down here. Circumcircle. Q be a point on the circumcircle of the triangle. Let V and W, oh my goodness, be the feet of the perpendiculars from Q onto CA and AB respectively. Maybe that's, looks like this. Prove that the triangles PBC, oh gosh, okay, I didn't mark my points in. P be the other end of the diameter through Q. Oh gosh, I feel like that could be anywhere. I just feel like there's so many points and stuff. Right, so V and W, we're still going. V and W be the feet of the perpendiculars from Q onto CA. Oh, I don't think I'm going to be a geometry streamer. Is Q on the wrong side? Or on the same side of the chord BC as I didn't even read that. I didn't even read that bit. Right, good, okay. So I need to redo all of that. And I drew a dotted diameter for no reason. Okay, read the question. I just feel like my diagrams always turn out to be absolutely useless. What is this? The triangles? No, okay, I think I'm stuck. I just don't know what I'm going to do at all. I don't go into them knowing anything, right? V and W. And then P is all the way over here. Prove that the triangles PBC and AVW. Q is opposite. Or similar. And that's the circle plus the I just don't go into these with any ideas. So I'm going to think about it. Oh, it's 6:15 already. I'm going to think about this for almost no time. Angle chase. It's the only thing I've got, I think. Do I know anything about PVC? No. You kind of pick the point P and then you get the point Q. They're opposite, so you get some. Well, you would get right angles if you joined B to P, B to Q, and C to Q. If you wanted to do that. Would I want to do that? Not sure. Similar triangle is not that bad, right? It's just an angle chase. Maybe. What would rank higher? Category theory or BMO geometry? Just all like, why have I picked the circle one as well? Oh dear. I'm a bit thrown by this P is opposite to Q sentence. Other end of the diameter. What do I know about diameters? Just a 90-degree factor thing, I think. So maybe should I break symmetry? Aim for one of them. Just join B to Q. all these right angles. What have we got then? So, cyclic quadrilateral. This one is it's 180 minus that one, which is also true for P. So those two are the same. So I just need to check that this one is the same as something in that triangle, and then I'm good. PBC and AWV. So maybe, is it just an angle chase? It could be just an angle chase. I'd like it if it was just an angle chase. Which one do I think it is? Oh, I don't know. Maybe V, just to be backwards. You found another function question for us. I think we might save it for next time. RFL for finding it. We might save it for next time. Because I think I'm going to call it a day very soon. I'm going to have a feeble attempt at an angle chase on a tiny diagram, and then I'm going to call it a day, I think. So, feeble attempt at angle chase, let's go. We've got a bunch of right angles. Ooh, is there a tiny version of the diagram in here? That'd be nice. That'd be cute, wouldn't it? Tiny version of the diagram. Oh, probably not. I mean, there's some right angles. You could draw a circle. You could draw a circle through those points. I don't really want to. Do I? No, I really don't. It's quite tempting to join B to Q. I just feel like that's a disaster, especially on my diagram. Because then I get this like a... I know there's a right angle from P up there to B to Q. So I get kind of 90 minus beta. And then what, right? Then what? I haven't used those right angles yet. But I don't want to, what do I want to do? Give these things names? It says 90, right? I know I'm playing both sides, so I always come out on top. Yeah, no, I'm not up for this angle chase, I think. Just not enjoying it. Not in. Tapping out of the angle chase. You can keep your angle chases, BMO1. I never liked them anyway. Right, good. On that note, I think I'm going to stop trying to do this. We're going to put the BMO, we're going to find the 2003 one and put it on screen as a kind of next time. 2003 for question 4, we're told. Is it this? Question 3 or 4 or something? Oh yeah, okay. I see there's several functions in this one, which looks like this. So next time on the stream, possibly. If not, the arithmetic progression is this thing at the end. Wow, a function is your favourite question ever. Set of non-negative integers into itself such that on odds it does this. Difference of two squares with a 6. That's funny. Okay, there's a 6 in this question. And also, f of 2n is greater than or equal to f of n. That's a strange rule. Just the evens, it just increases on the evens. How many numbers less than 2 and 3 are there in the image of f? I'm surprised you can say, because can't you maybe even one's enormous? That is funny. Oh, into itself? Is this... That's not trying to tell me that it's... Ooh, no. Do I care about this? It might be... I'm surprised that that's enough. Because that feels like, can't I just make f of 2? I mean, I don't know what f of 1 is. It doesn't tell me any of the information that I normally get in a question like this. Brilliant. What's that? BMO 2 2003. Good. Okay. Maybe next time. Let's find out. Right, but I'm ending the stream, I think. Thanks for tuning in. Thanks for hanging around for Chill Maths, which is involved doing BMO questions as fast as I can, or not doing them and giving up in a half. Either way, tapping out quickly. Right. Okay. We'll call it there. Thanks for joining in. If you see an ad at the end, then I think you're allowed to just walk away from it, because this is the end of the stream. As Herb taught me to say, I'm ending the live stream. Have a good weekend, everyone. See you next week. Bye.